Okay, so when you are given an xt graph, a position time graph, the slope of the line is the velocity. If you look here and you calculate the slope of this line, you'll discover that the slope is 1 meter per second, and that's going to be equal to the velocity. Because it's a straight line, the slope is the same at every moment in time, at every point along that line. And so when we come down to the velocity time graph, we know that the velocity is 1 meter per second. And so I'm just gonna put a lot of dots here at 1 meter per second because it's 1 meter per second from 0 seconds to 7. And your VT graph is gonna look like that. It's gonna be a horizontal line at positive 1 meter per second. The way that a motion map would look, you would make your line 1, 2, 3, 4, 5, 6, 7 or whatever and then you would take a look at your xt graph. What's our starting position? Starting position is the y-intercept, so it's 0, and then you're going to go at 1 meter per second every second. So you're going to have a bunch of dots here. It's almost going to be too tight for me to even draw arrows, but I'm going to draw my arrows in. And that is what your motion map would look like. And start. Now, sometimes you will discover that you have sort of like a graph with sections. Like this one, there's a couple of different things happening in the graph and everything changes at 2 seconds. And so what you would need to do is just take each segment by itself and do exactly what we just did. In those first 2 seconds, what's the slope of that graph? The slope here is 0. So that means the velocity is 0. So from 0 to 2 seconds, the velocity is going to be 0 the whole way. So it's just going to be a horizontal line on 0. And here, the slope of this line, if you do it, I would use this point and this point. Sorry.
Please release your students at this time. Wildcat Nation, please join us for a moment of silence and reflection.
Okay. You will discover that this is a slope of negative 1.25 meters per second. So you would come down here and a negative 1.25, that's where you're going to be. So that would be the graph. And then you would do your motion map the same way that you kind of did the first one. You're going to start at 0 for 2 seconds. Or sorry, no, you're not going to start at 0. Where are you going to start? You are going to start at 5. So 1, 2, 3, 4, 5. Here's where I'm going to start. And for 2 seconds, I'm going to stay in that position.
Thank you.
Then I'm going to go a little more than 1, and I'm going to go back to the 0 line. So your motion map would look like that. Finally, sometimes you're not given the position time graph, you only have the VT graph. And so you've got to kind of read backwards. Now, the only thing that you really can't get from a VT graph is the starting position. So you get to pick that. I'm going to pick a starting position of like, let me just pick 3. I'll pick that as my starting position. You could pick 0, -2, -10, like you could pick whatever you wanted here. So for the first 2 seconds, okay, I am going to have a velocity of -1 meters per second. So I am going to have a velocity of -1 meters per second for 2 seconds. So that would be my first 2 seconds. Then I'm going to have a velocity of 0. Now think about what that means. So that means that the object is staying in the same position. It's not moving. So that means that if I'm at 1 meter per second, 1 meter position, I'm gonna stay there, and I'm gonna stay there for 1, 2, 3 seconds. So my line would look like that. And finally, in those last 2 seconds, I have a velocity of 2 meters per second. So in this second, I'm gonna go 2 meters in the positive direction, and then I'm gonna go 2 more meters in the positive direction. And that would be my graph. My motion map is going to look like this. Always use, if you can, always use the position time graph for your motion map. And depending on where you started, it has to match up. So I need to start at 3 here. Then I'm going to go backwards at 1 meter per second for 2 seconds. Then I'm going to sit still for 3 seconds. Then I'm going to go forward for 2 seconds at 2 meters per second, like such. And that's going to be my motion map.